Hello, welcome to the teacher instructions for the measurement lab. Station 1 is titled Volume is Sweet. For this station, you'll need sugar cubes and you have to arrange them on placemats, about 15 to 20 for each student. The goal is for students to calculate volume. By building shapes with the cubes, the volume of one cube will be 1 millimeter. That is a standard size for sugar cubes. And then they will understand that multiplying the volume of one cube times the total number of cubes will get you the total volume for whatever shape they build with the cubes, even if it is not a perfect prism. They could be angled in different ways, and it'll still have the same volume. Next up, Station 2, Measurement Mania. For this station, you will need rulers, yardsticks, and tape. It's very important to have foot-long rulers, perhaps 6-inch rulers, and then yardsticks and tape. So to set up, just place tape strips of various lengths to the floor. You'll probably want to make some that are a little longer, like maybe many feet, and some that are smaller, maybe many inches. And the objective is using different sized tools to measure objects. So the students will measure each tape strip with a yardstick and a ruler, and they will learn that it's more efficient to use the ruler because it has smaller units when you're measuring smaller tape pieces, and use the yardstick because it has larger units such as feet when you are measuring the longer strips of tape. I believe the capture sheet for the lab has inches and yards. Feel free to change that to centimeters and meters if that is what you have on your rulers and yardsticks. Station 3, sneaky scales. You'll need a kitchen scale, like a vegetable scale, or just a small, like scientific lab scale. And you'll need a bathroom scale, one that you can stand on ideally. To set up, just put the scales out and provide some large or small rocks and pebbles to measure. The goal is the same as the last one. Use different sized tools to measure objects. The process is they will weigh the rocks and then they will weigh themselves, and they will determine when it's more efficient to use each scale. This one will be a bit more obvious because they will not be able to weigh themselves on the kitchen scale. And if you don't want to have your scale broken, I would suggest you tell them not to do that. It takes a bit away from the discovery piece, but it's still probably good. Okay. Station 4 is a balance. So for this, we want to balance the kind of balance where you can put two objects on each side and compare them, not the kind where you're amassing something. You'll need a kitchen scale as well, and rocks labeled and weighed. You need to weigh the rocks before using them. And what I would suggest for this activity is that you make some of them, so probably all of them, you would weigh them in grams, but you could change some of them to kilograms and change some of them to milligrams so that the students have to convert them all to grams. Then they will have to predict, like is rock A going to weigh more or less than rock B when you put it on the balance. And to predict, they need to get all of the measurements to be the same unit. So if you put them in different units to start with, they have to practice converting, which is one of the goals of this. They can then check their predictions with the balance, and that's sort of the fun piece of this. All right, next up, Station 5, speedy sprinting. This is an outdoor one, although if you have a gym, that could work as well. You'll need an open space, at least 50 meters or yards long, and a stopwatch. Something else you could do is 25 meters or yards, or 20. Just the data in Station 6, you may want to edit that. To set up, you'll need to measure distances from a point. Option 1 is using the metric units. Option 2 is using the customary. Just use whatever is useful to you. And There's nothing on the capture sheet about that, so it's the students will fill in the distances, so there's nothing to edit on the capture sheet for Station 5. You'll measure one that's 50 centimeters or inches, then one that's 50 meters or yards, and for the 50 kilometers or the 50 miles, you could maybe show them a map of a common place that is that distance away, because you aren't going to measure that far, right? Or you could tell them that it takes, I don't know, an hour to drive to a place 50 miles away. And you're going to ask them, which distance would you like to have a race, just a sprinting running race? And they're going to realize that the 50 centimeters or inches is super short, right? Because 50 inches is like 4 feet, 50 centimeters is less. And then the 50 kilometers or miles is way too long to sprint. So hopefully they'll come to the conclusion of meters and yards. And this topic is about determining which units are most appropriate for a situation. That's our objective here. The process is to observe all the distances and determine which would be the best for a running sprint. Then the students will race and record their time on the capture sheet. So make sure you're timing the students. You might want to have them go like 3 at a time or 4 at a time or so. Have another teacher stop watching. Station 6 is scorekeeping. You need to complete Station 5 first. So if you're having a rotation of students, maybe just have only 5 groups, and then they can start at Stations 1, 2, 3, 4, and 5. Because to do Station 6, you need to have already done 5. All right. And that's because the supplies include the times from Station 5. They will use elapsed time in a real-world situation and complete the information on the capture sheet. And we will go to the capture sheet now. So this is up here. I am in group. I start at station. That's just if you are having multiple groups. Station 1, the instructions are on there. Same thing for Station 2. Problem 2 on Station 2, they're just writing R or Y for ruler or yardstick. If you change that to meter stick, that's fine. And then Station 3 is sort of the objective there. Station 3 is just some predictions and then using the scales. Station 4 is weighing. There's some space at the bottom of Station 4 for them to show their work with converting all those units to be grams. If you feel like it, you could also measure in ounces and pounds, but then it would be hard to use tons, I think, for measuring little rocks. So milligrams, grams, and kilograms are probably best for that. Station 5 is mostly just fill in the blanks. Nothing teachers would need to edit. Station 6, teachers could edit those times if you change the distance of a race. And then it's just some one little calculation. You could add some more calculations if you would like, maybe on the back. Okay. Here's a link to the full lesson slides. And we have some signs for your classroom for each station. I will slowly go through these. They're printable, they're all black and white. And that is the end of our tutorial for the measurement lab. Good luck.